Alright, let's try another example. We have some random trinomial here, degree 2, and see how it would go. In this case, we want to emphasize the idea of completing the square. It's a famous idea and it comes in handy often. What you want to do is take this creature right here, 2 minus 5x minus x squared, and manipulate it so that we get rid of that 5x. That's another way of saying we want to complete the square. Here's how you do it. You could well, I like to work with positives, so I'm going to factor that out. X squared, it's just my preference. There's nothing special about this way of doing it. This way I keep my leading term positive, and now I try to go with my standard x squared plus 5x. I take half of that, which would be 5 halves, and I square it. That would give me 25 over 4. And then just to make it the same as it was before, I need to compensate for it. Here, using the negative, I subtracted a negative 25 over 4, so if I added a 25 over 4, we would call that even. See, if you distribute that, makes a negative. This makes it even. 25 over 4. Now I've got a 2 here, and I got a 25 over 4. This is 8 over 4. So I've got 8 over 4. I'm putting these two together in my mind. My brilliant mind. I could do this in my head. 8 over 4. That's this one. 25 over 4 gives me 33 over 4 minus. Now this is a complete perfect square, so it becomes x plus 5 over 2 square. And so you've taken the original trinomial here and wrote it in a nicer way. That helps you a little bit because you could take the same problem here, and now it looks like this. Now it looks like the integral of 1 over 33 over 4 square root minus x plus 5 halves squared dx. You may say, well, how is that going to help us? Well, you could do a v sub here. That v equal to x plus 5 over 2. Then the differential of v would be equal to the differential of x. Little baby dictionary. Change that, becomes 1 over the square root of 33 over 4 minus v squared dv. And that helps a little bit. Now you try to match which trig identity that looks a lot like. And I would go with the following idea. I would want 33 over 4 minus v squared to be equal to 33 over 4 minus 33 over 4 cosine squared theta. Because I know that if that was the case, this looks a lot like a constant minus something square. So the thing that will work there is the 1 minus the cosine square, or it could have also been 1 minus the sine square. This way I know that I'm going to be able to factor out the 33 over 4 and it won't bother me, and I'll just be left with a cosine squared theta, which I can then turn into a monomial. So that's what I want. Now that's what you want. Get rid of the 33 over 4s. You're really saying that you want v squared is equal to 33 over 4 cosine squared theta. Or you're really saying that v should be equal to square root of 33 over 4 cosine theta. This sub is the one that will work. It'll make your life a lot nicer. I'll let you finish that problem. I just want to explain the complete the square part. Once you've completed the square, it looks like a lot of the other ones that we've done today. So I'll let you take a crack at that one. Alright, that was fun. We'll see you guys here next time. Peace. Don't watch too many of these videos in one day. Always listen to good music when you're watching them. Alright, see you guys.